This video is sponsored by r/dv. This subreddit has cool stuff like art, music, memes that sometimes aren't dead memes, and discussion threads. Subscribe today and gain absolutely everything. Or nothing. You won't know until you subscribe. Okay, so this movie exists. And I hate it.
If you're watching this, you must be clinically depressed. I am watching this because I've got no friends. Last time I got a hug, I was 17. When people say socialize, what do they mean? I've got no friends, and neither do you. You've got no friends, and neither do I. We've got no friends, and that's why we're watching this.
The Little Panda Fighter is a terrible, cheaply animated, lazily made movie released by Video Brinquedo, a Brazilian movie studio specializing in making terrible movies. Did I mention that the movie's absolutely terrible?
It's so bad! Why would anyone even think?
Anyways, before I get sidetracked by my absolute hate for the movie was released very soon after Kung Fu Panda in an attempt to capitalize off confusing people into buying it. And apparently it did, to the point where Amazon mentioned in the title that it is not Kung Fu Panda. It makes sense how it confused so many people. Just look at the two DVD covers. Anyways, the movie is known for its many faults, such as plot holes left, right, and center, irregular speech patterns, including the speech suddenly speeding up and slowing down with no reason whatsoever, and terrible character assets, comparable to Struinsky and the Mysterious House, but we won't be looking at that in this video. Instead, I will be introducing real-world logic to this movie and analyzing the physics flaws behind it. There are many notable scenes in this movie. Actually, I retract that statement, this movie makes no sense at all. One of the main scenes in the movie, however, or at least the only one I can remember, is a scene where two bears are boxing. This scene is not only terrible in the context of cinematography, but it also has its fair share of physics flaws. Here's the clip. How did I end up here?
What a battle this is, folks! Just one round in and Teddy is already taking a licking! Who would have thought a panda like this could have such fancy footwork?
Get ready, Mystery Bear. I hope you have your insurance policy paid up, because I'm about to make mass mincemeat out of you.
I'm afraid you're mistaken, Thunderchump, because your time is up.
You gotta get down here, Orsini. Freak Teddy's getting his butt kicked all over the place. I haven't seen a brawl like this since Polaris the Demolisher ruled the ropes. Now this is worth buying a ticket.
Ladies and gentlemen, this is the fight we could only have been dreaming about a year ago. Believe it or not, Freak Teddy may have met his match.
Oh, I don't believe it. I just bought those fixtures last week.
Folks, tonight we have witnessed one for the ages. A real shocker, my friends. The great bear of mystery has delivered the knockout punch heard around the world.
The first thing I decided to do was find some basic measurements to aid me in finding the flaws in this clip. First, I determined the dimensions of the boxing ring. With some research, I was able to find that the average boxing ring is 4.9 to 6.1 meters wide, and the platform is generally raised 0.91 to 1.22 meters from the ground. For ease of calculations, I settled on the boxing ring being 6 meters wide and 1 meter tall. Then I found the masses of Polaris and Freak Teddy, the two bears boxing against each other, whom I will call PO and FT, because I'm not going to keep saying those names. Since PO is supposed to be a polar bear, I found the average mass of an adult male polar bear, which is 450 kilograms. Since FT is supposed to be a grizzly bear, I found the mass of a grizzly bear to be 270 kilograms. Notice how I'm saying supposed to, because do these really look like bears to you? Anyways, for the sake of reference, I found the maximum amount of force required to break a human femur, the strongest bone in the body, which was about 4,000 newtons. Now we get into calculations and finding values. I figured that the best place to start was finding the height of the bears. Now this wasn't hard at all, and required no calculations at all. Since both bears have approximately the same height, give or take a few centimeters, I kept a note of this. Using the still at 1926, I observed that FT was taking up half the width of the boxing ring. And since we previously determined that the boxing ring was 6 meters wide, it wasn't hard to conclude that his and PO's heights were both 3 meters. Let that sink in, just imagine 3 meter tall bears. One other thing that I noticed when I watched the clip was that at the minute mark 2013, when FT is falling, he seems to be falling quite slowly. And it occurred to me that gravity may be acting differently in this bootleg universe. So using my video editing software, I found the time that it takes him to fall to be 1.59 seconds. Then I found the vertical displacement of FT, which appeared to be 3 meters from the boxing platform. Using PO's height for reference, and since the platform is 1 meter off the ground, his height from the ground would be 4 meters. Since FT stopped flying and started falling immediately after hitting the light fixture, his initial velocity would be 0 meters per second in the vertical direction. Using a kinematics formula to solve for time, I ended up calculating an acceleration of 3.16 meters per second squared, which would be our acceleration due to gravity, less than half the average gravitational acceleration on Earth, 9.8 meters per second. This may explain why the bears are so tall, but I'm not going to get into those details. Now that we have these basic values figured out, we can begin to deconstruct the clip. The main part of the clip I will be focusing on will be when PO kicks FT, sending him flying into the light fixture, then falling to his death. No, but that's what should have happened, so this god-awful movie could just be over. Unfortunately, a person would have to fall from a height much greater than one story to be killed. Since FT leapt toward PO before being sent flying, I wanted to find FT's velocity immediately before being kicked to determine his change in velocity later on. Using the video editing software, I was able to find the duration of his jump to be 0.57 seconds. I then found his displacement from his starting position. Since he jumped across half the boxing ring, his horizontal displacement was found to be 3 meters, and since his maximum height was half PO's height higher than him, his vertical displacement was 1.5 meters. I calculated FT's horizontal velocity using the displacement over time formula and found it to be 5.26 meters per second. I calculated his final velocity using one of the kinematics formulas and found it to be 1.73 meters per second. Then I calculated his total velocity using the Pythagorean theorem and got an answer of 5.54 meters per second. In order to find the change in velocity from FT's final velocity to his initial velocity after the kick, and for future references, I determined the velocity of FT after the kick. Using a video editing software, I found the time that FT was flying between being kicked and hitting the light fixture to be 1.66 seconds. I then found FT's displacement. Since FT at his final point was the same height of PO above him, FT's vertical displacement was 3 meters. To find his horizontal displacement, there was a bit of guesswork that needed to be done. Visually, it was shown that FT had flew about the same length past the boxing ring as another boxing ring, and since he started flying from halfway across the boxing ring, his horizontal displacement could be concluded as 9 meters. I solved for the horizontal velocity using the distance over time formula, giving an answer of 5.42 meters per second. I used one of the kinematics formulas to solve for the initial vertical velocity and got a result of 4.43 meters per second upward. Using these two values plugged into the Pythagorean theorem, I found a velocity of 7 meters per second. Then I solved for FT's final velocity. Since the horizontal velocity would remain constant, I used the value obtained previously. Then I used 0 as the vertical velocity, since at this point, FT stops moving upwards. For this reason, FT's final velocity would be 5.42 meters per second. Using this information, I solved for the change in velocity, getting a value of 12.54 meters per second. Now this is where the numbers begin to get crazy. To set myself up to solve for the force exerted by PO to kick FT, causing him to fly, I solved for the acceleration, since it can be seen that FT went flying the instant PO kicked him, and there was practically no follow through. I used the smallest value for the time I could, while staying within 2 decimal places, and set the time of the kick to 0.01 seconds. I solved for acceleration using the velocity over time formula, and prepare yourselves for this. I got a whopping 1,254 meters per second squared. Using this acceleration value in FT's mass, I solved for the force needed by plugging the values into the force equals mass by acceleration formula, and got the insanely large value of about 340,000 newtons. Bear in mind, pun intended, that the force needed to break a human femur is 4,000 newtons, and this blow was delivered to FT's chest. If this scene was more realistic, it would look something more like PO's delivered kick, ending up going through FT's chest, killing him. I then determined how much kinetic energy would be imparted to FT by PO by using the kinetic energy formula, using FT's mass and the change in velocity during the kick, and got yet another ridiculously large value of about 21 kilojoules, the same amount of energy imparted when 5.2 grams of TNT are detonated, or the same amount as the recommended daily intake for an average adult for 2.5 days. Where PO is getting all this energy is unclear, as he is never seen eating anything for the entire duration of the movie. Finally, I solved for the momentum of FT at 3 different points, as well as the momentum of PO's kick. First, I found the momentum of FT immediately before being kicked using the final velocity of his jump previously found. The result was 1,495.8 kilogram meters per second. Then using impulse, I found FT's momentum after the kick. I plugged in the force of the kick as well as the time duration of the kick, even though it is almost nothing at all, and there's almost zero follow through, and got a solution of 3,385.8 Newton seconds. I then found the momentum of the kick using the formula for the change in momentum, and got 4,881.6 kilogram meters per second. Realistically, this would cause some significant damage to FT, considering that all this momentum is concentrated at one point on his chest, and even some noticeable damage to PO's leg, considering all the shock that would have to be absorbed by his leg. After this, I wanted to find out how much momentum FT would be hitting the light fixture with. It was observed that the light barely swung, absorbing all the shock from FT hitting it, with nothing happening but the beam holding the fixture snapping after some time. First, I calculated momentum with which FT hit the light, using his final velocity after being kicked and his mass. The result was a momentum of 1,463.4 kilogram meters per second. I then did some research about the fixture itself. It best resembled a Japanese paper lantern, so I checked Amazon for one and found one, finding the mass to be 249.5 grams. I then did additional research and found out that the average light bulb had a mass of 20 grams and added these, getting a total mass for the light fixture in the movie to be potentially 269.5 grams. I then used the concept of conservation of momentum as well as the mass of the light fixture to find the velocity at which it would be moving after being struck, getting a value of 5,430.05 meters per second. Although other factors such as air resistance would surely slow this down, the light fixture should definitely have been completely destroyed. It shouldn't have simply fallen, it shouldn't even be at this point. In conclusion, The Little Panda Fighter is a terrible movie with terrible physics. I really don't want to talk about this movie anymore. I am so tired of talking about this movie. So, bye. This is the part of the video where I usually would put my outro, but I'm just really tired today, so bye.